Welcome to video 30. We are looking at subprograms, basic use, local and global variables. So the purpose of this video is to understand the basic syntax and use of subprograms in Python, to understand parameters and the passing of data between the main program and a subprogram, to understand the significance of local variables, global variables and scope. So in this video, guys, we'll do some demos first and then tackle some more theory and background afterwards. So just a reminder then that in the Schoology folder for the Python Monster resources we have two PDF documents. The first one organizes the videos in playlist order, and the second one provides a little bit more detail with the videos organized by sequence. So let's crack on and do some Python demos. In this demo, we're going to create a program to do some trig using two subprograms. When I've done this, I'm going to do a bit more theory around how the program uses local and global variables and how we define scope. Now, it's always a good idea when you use subprograms to make sure that somewhere in your code you have commented on each of the subprograms and what they do. And the best way to do that is to describe the input parameters, what the subprogram does, and whether it's a function that's going to return a value to the main program or a procedure that won't return a value. It's also common practice to state the data types as well of the parameters, so that anyone maintaining your code or using your subroutines will know how to use them without generating a syntax error. So have a read of the block comments on the screen, and this should make it pretty clear about the purpose of the program and the definition of our two subprograms. Pause the video if you need to, and otherwise let's crack on. So the first thing that we need to do, as this is a trig related program, is we're going to need to import the relevant functions from the math library. And whenever you import from a library, guys, the line of code to do that should always go at the very top of your program if possible. So we will say the format for this, we will want to do from math. So I'm going to be specific about the functions that I want to import rather than importing the whole lot. So we'll say from math, and then we want to do import, and then we want the sine function, we want the cosine function and the tangent function. And then one more, guys, because Python doesn't work in degrees, it only works in radians, so we need to import the relevant function to translate degrees to radians. So we want radians as well. Okay, so that's our import done. Now what we need to do is we need to define our first subprogram, which is going to be the procedure that simply prints out a message on the screen. So what I should do to start with really is to pop a comment at the top, and I'll put receives a message parameter, and then I'll put in their string, so we've got the data type, to print to the screen. Okay, and then we want to actually define our subprogram, and the syntax for doing this is to say def for define. Okay, so this is what exclusively tells Python that this is a subprogram. Okay, so def, and then we want the name of the subprogram, so that's going to be print intro, and then we want opening brackets to put in our single parameter. So this is going to be the string message that gets passed up from the main program to print out. So I will put in here output message. Okay, and then, guys, watch closely, because the syntax, you will recognize this from previous programming constructs. So we have the colon, and then we need to indent. Okay, so there we go. Why do we need to do that, guys? Because this is another example, just as we had with iteration and with condition selection, where Python needs to be told that this is a self-contained block of code that needs to be interpreted as such. So we use the colon and indentation with this programming construct, as well as the other two that you've come across. Okay, so we need to indent here. So we simply need to print out the message to the screen. Okay, so we print out output message. Okay, and that is the definition of our very first subprogram. Okay, and of course this is of type procedure rather than function. So you see here, guys, nowhere in that code are we returning a value to the main program. Okay, next thing we need to do is we need to define our function. So this is the one that's going to take the number from the user in degrees and then return the trig equivalent. So let's put a comment in which says, let's get rid of the indentation. Let's say receives a number in degrees and returns the cos, sine or tan equivalent. Okay, and I will put in a comment that says degrees will be, I'm going to ask the user to input either an integer or a float, so the data type will be float. So we'll say degrees in float, and we will also say type is a string, okay, because we're going to ask the user to tell us what type of trig calculation to do. Okay, so same as we did before, let's just scroll up a little bit. We want to start off with def, always start off with def, followed by the name of our subprogram. So this will be calc, and then we want trig. Our parameters are going to be num, which is the degrees from the user, followed by the type. So I'm going to put in there trig type. So that's the variable name for our parameter. Okay, so trig type. Okay, colon and then indentation. So we want to initialize a return value. So I'm going to put in here initialize variables, as we always do. Let's get the spelling of that right, because that would be very annoying if not. Initialize, okay, variables. Let's pop in a general comment here which says, oh no, let's do our variable first. So let's do return value. So this will be the variable that contains the value that we will return back to the main program. So I'm going to initialize that as 0 to start with. And let's just put in a general comment that says calculate results, okay, because this is the part of our code which is actually going to do some maths. So what I'd like this subprogram to do is to return a value of -1 if the user does not provide us with the correct type. So if it's not cosine, sine or tan, we will return -1, and that means in the main program we can cater for an erroneous input. So it's a bit like, I suppose it is, it's a type of data validation really, isn't it? So what we will do is we will say if type, okay, not in, and then the collection that we want to define, of course, is the same as our expected input parameters. So we want sine, and then we want cosine or tan. Okay, so one of those three. If that's not the case, okay, then we are going to say return value is equal to or becomes -1. Okay, else that means we've got some valid parameters from the user. Okay, so else, now the first thing that we need to do is we need to convert the number from the user to radians. So all we need to say is num becomes, and then we want the radians function with the number inside, which of course is the parameter and variable num. So num is reassigned with the value of the radians version of the user input. Okay, so that needs to be done for all calculations. So we will put that at the top. Then we need to cater for which type of trig the user wants us to do. So if trig type, okay, is equal to or equates to sine, okay, the string sine, then we want to do the sine calculation. So that will be assigning return value, okay, will be quite simply it's sine of, okay, and then this is the sine function from the math library. So we just want to put in our new radians version of num. And then actually what we can do is we can do a copy and paste and just tweak, can't we? So we'll say elif, okay, and then we can copy this. Let's pop that in. So we want elif trigger type is equal to cos. Okay, then we can copy and paste this across. Okay, so this time we want the cos function from the math library. So cos, and likewise guys, we will have else now because we have nothing else to do after this. So else, okay, and then of course return value becomes, and that will be the tan. That's the last one left. So tan of num. Okay. Now what I am going to do, and I'm going to come back to this a little bit later on, but I'm just going to put a sort of placeholder print, this sort of debugging print holder place statements in here. I'm going to put in returning the calculation, okay, and you will see the significance of this a little bit later on, okay, because we are going to tweak this code because I want to show you a couple of other things after we have got this one successfully done. So print return the calculation, and then let's put in a comment that says return the final value, and this is where we're going to return our value back to the main program. And quite simply we want to use the keyword return and then the name of the variable where we have stored our return value or our calculation, which of course is return value. Okay, so that is, let me just zoom out so you can see the whole thing in one go. Okay, so now we have our two subprograms defined. Okay, so there's our first one and there is our second one. Okay, so now all we need to do is to write our main program. So what I tend to do, I mean, you don't have to do this, and you can if you are going to do something similar, you can use whatever format you want to, but I tend to put in a comment and then a sort of dividing line, and I put in here main program, and that's just so that you can see, particularly in larger, more complex programs, where your sub programs finish and your main program starts. Okay, so this is going to be our main program. So the first thing I'm going to do, because we don't use constants a great deal in my videos, I'm going to define a constant, and this will be a string constant. So let's put it in the message. Let's just zoom up a little bit, guys, as well, so you zoom in, and our constant will be the message that we want to pass to our print procedure. So I'm going to say MSG, uppercase, guys, because it's a constant, and then we will simply say what should we say, let's say this program converts degrees to the cos, sine or tan equivalent. Okay, okay, that should do nicely. All right, so we're going to pass that across as a constant through to our subprogram. So the next thing we need to do is we actually need to just notice, guys, actually this is going to cause a problem because I haven't got rid of my indentation, so that needs to go right up against the margin. Okay, that's better. So that's our message. Next thing we need to do is we need to call, okay, subprogram, and then we'll say to print out an intro message. Okay, to print out an intro message for the user. So all we need to do now is we need to call our procedure, and if you remember, it was print intro, so this is the name. Okay, so print intro, and then we need to pass into that the parameter that we're going to make available to the procedure, so that will be MSG. So we're passing over or passing up the parameter MSG, which is a variable containing the string this program converts degrees to the cos, sine or tan equivalent. Okay, so and in terms of calling a subprogram, guys, it's as simple as that really, for particularly for a procedure. And the next thing we need to do is we need to get some input from the user. So guys, let me just move this across. I'm being very slack with my indentation here. Incidentally, if I had forgotten, let me just zoom out a sec, if I had forgotten to move my code over to the margin, what would Python have done? Well, it would try to have assumed that actually this MSG line of code here was still part of the calc trig function. It would probably have returned an error because I would have had some code after the return line of code here, but nevertheless that would have been the initial assumption. So there you go, just showing how important it is to get your indentation in the right place. By example, guys, all of that was planned, I promise you. Okay, so let's get some input from the user. So let's say we want to comment first, so let's get user input. Okay, we want type and number, so we need two inputs from the user. So let's start off with type. We'll just move this down a little bit. There we go. Okay, so type from the user. So let's say quite simply type equals, so that's going to be our variable. Okay, and this is going to be a string type, so we don't need any casting, so it'll simply be input, and then I am going to pop in a new line character. Okay, and let's say please input the trig type. okay, which can be sine, okay, or cos or tan, okay, and then I want my usual two arrows, so that'll be the value assigned to type, one of those three. All right, let's just sort that out. There we go. Good. Okay, the next input that we want is going to be a float input. Okay, I have chosen that I'm going to allow the user to input parts of degrees as well. So let's say number equals, okay, and then we want the float casting of the input of, okay, and then our prompt. So let's say please input an angle, okay, in degrees, to convert, let's say to convert to the trig, okay, followed by my usual bits in the end there. Okay, so we've got our two inputs, guys. Okay, what do we need to do next? Well, quite simply to call the subroutine, sorry, the subprogram, to do the calculations. So I might well, guys, in my videos say subroutine instead of subprogram by mistake, because traditionally subprograms have always been called subroutines. Okay, so I myself have to get used to the different terminology. So subprogram. So let's say call the subprogram. Okay, and we want to get the trig of the number, and let's put degrees. Okay, just for clarification. Now this time, because our subprogram is a function returning a value, it is normal practice, you don't always have to do this, but it's normal practice to have that return value assigned to a variable so that you can use that elsewhere in your main code. So what I'm going to say is, let's assign to result. Okay, the value passed back, we need to call trig, and then we need to pass in our parameters. We have two of them this time. We need to make sure, guys, always with subprograms, when you're calling them, you need to get your parameters through the right way around. Okay, so the first one that we need to pass in is the number, okay, followed by the type. I think, is that right? Let's go up and have a check how we defined it. Okay, so we did indeed, guys. Okay, we put them in this order, num first followed by trig type. So we need to call our subprogram using parameters in the same order. Okay, and that's all we need to do. All right, just a single line of code, and that will give us our result. So our result is going to be a float. So what you've seen me do in previous videos, of course, is to round. So I'm going to round to 4 decimal places. So let's put a little comment in that says round result to 4 dp for decimal places, and then I'm going to reassign to the same variable. Okay, so result becomes the old result and then rounded. Okay, so rounded to 4 decimal places. So result comma 4 will give us 4 decimal places. Okay, next thing I want to do is I want to capture an error. So you remember we returned -1 if the user gave us a type that was invalid. So let's cater for that first. So we will say if result equates to -1, okay, then we need to print out a suitable message, an error message. So let's say print, and let's say error in type passed to parameter. Okay, all right. I'm not sure in reality whether that would be the type of message, guys, because the user won't know what a parameter is, but I'll leave it like that because it's useful for you guys. Okay, else we can do a proper printout now, can't we, because we've got a proper result. So else we will say print the result, or print a valid result, and our valid result, we want format for this, so I will say, let me just move that up a little bit so you can see more clearly. Let's say print, okay, and then I'm going to want a new line again, so let's put in a new line character, and I will say the type sorry guys, just thinking aloud, type is actually a variable, so we need to put in there a concatenate, okay, and then type is a string, so that's cool, and then we want to concatenate with, and this time we do want to convert to string. Now what I'm going to do is I'm going to take the original data type was a float, guys, okay, but I am going to print out the integer version of the original input. Okay, and that's really just to show you how you can use these multiple evaluations. So string of the integer conversion of number. Okay, I mean, you don't have to do that, guys. I'm just giving you an example of how you can use multiple evaluations in a print statement. Plus, and then we want the rest of our sentence. So degrees gives. Okay, is that correct? The type, yep, okay, and then we want plus, and then we want another string casting of the result, which of course is not a string type. And I think that should work fine. So we've got string plus type plus string. Oh, I need to put of in there, don't I really, because that's going to be a bit of a strange sentence otherwise. The string, the type of, okay, the number. All right, so that looks a little bit better. Okay, plus degrees. Have I got too many brackets in there? Actually, string of int. String of int of. Yeah, I only need 2 brackets there, don't I? And then I want a bracket at the end. Yeah, I was going to say that looked a little bit over the top, that. So I think that should do the trick. So let's just zoom out so we can have a look at the entire program. Okay, so at the top here we have an area of our screen, or area of our editor, that is dedicated to our subprograms. So that's at the top. By the way, guys, subprograms always go at the top of the program, your main program. Subprograms always go at the top of your code in Python. Okay, that's not always necessary in other programming languages, but because Python is interpreter based, all of your subprograms need to be defined first before your main program. So there we've got our subprograms. Okay, and then underneath we have a little bit that tells us where the main program starts. Okay, and then further down we have our actual chunk for our main program, which is of course here. Good. Okay, so let's run this. Okay, guys, so yes, I'm not running the program because I just at the end of that part of the video I just noticed that there was a couple of typos. So I've changed type to trig type, and the other thing I've done also is I've taken out our rounding and I've put that in the relevant part of the code where we are specifically dealing with valid input. Okay, so that should give us a better result this time round. So let's try and run this, see if we get some sensible answers. So please input the trig type sine, cosine or tan. So let's put in sine. Let's pop in 45 degrees. Let me just move that over for you and zoom in. So 45 degrees. That gives us the sine of 45 degrees is 0.7071. Let's pop it in with a 1, which we all know, which is the sine of 90, which should give us 1. So let's pop in sine of 90 then. So sine, let's do sine of, and then 90. And that gives us 1. Okay. And let's also pop in an input which doesn't correspond to sine, cosine or tan. So let's put in something silly and a degree. Okay, and that says, okay, error in type passed to parameters. So that's catered for us passing back the -1. So that works as well. So guys, we have a solution that works, but I wanted to go back to Calc Trig and I wanted to have a look again at the way that we've used our return statement. So in our solution, we initialized a variable with 0 called return value, and then within our code, we assigned the value of return value with whatever value the calculation generated, and then right at the end of our block of code, we used the return statement once to return whatever value we wanted to pass back to the main program. So what I wanted to show you was this idea of using the return statement on multiple occasions, which we can do. So in actual fact, we don't need a return value at all. We can get rid of this, and what I'm going to do instead of assigning the result of a calculation to a variable is we're simply going to tell Python to return a value as soon as we want the program to do that. So we are going to change that to return -1, and likewise right the way through here, instead of assigning a value, we are going to ask Python simply to return, and again here guys, to return. Okay, likewise with tan. Okay, and we don't need these 2 lines of code here either. So what we've done is we've replaced the variable and we've simply used the return statement on multiple occasions. So we've catered in the code for every eventuality of a return value, including -1 to capture an error. So let's run that and make sure that it works okay. So let's pop in, let's do a cosine this time. So cosine, and let's do 45. Okay, and we get 0.7071. So that's worked okay. However, you will notice that we used to have a statement in here printed out on the screen which said returning the calculation, and you can see the statement here, but now that line of code is not being executed. So why is that, guys? Let's have a quick look. So let's move this over for you. The reason it's not being executed is because if we're asking Python to return, that's exactly what it does. So using the return statement in this way is the equivalent of using the Python break keyword. We're actually asking Python to stop executing the code and to return immediately to the main program with the return value that it's been given. Okay, so it stops the sequencing, running the sequence of code, and it immediately stops and returns at that point. And that is the reason why we don't get this line of code printed on the screen, because in our current solution that line of code is never executed, it's never run, because we have catered for all eventualities. So Python will always be returning something back to the main program before that line is ever reached. Something to be aware of in your code. Very useful to be able to do multiple return assignments, but you do need to bear in mind, of course, that a line or lines of code may not run because the sequence of code has been broken and Python is returned back to the main program. Okay, so that's our demo done for this video. What I want to do though is I want to explore this idea of local and global variables, and before we do that I just want to pop in a line of code at the bottom. So here I'm going to pop in print the variable num. Okay, and you can see, if I zoom in, you can see that PyCharm has underlined this. Okay, and the reason it's underlined it is because it says unresolved reference num. That's Python's way of saying I don't recognize that variable name. Now that's a little bit peculiar, isn't it? Because if we come up to the top here, we can see that we've used the variable num and it worked okay. So the question then is, why is num not available to Python at this point in the code? And this is something which I'm going to explore with you in terms of theory, because you need to know this for your GCSE, but I'm going to use slides to do this, guys. Okay, so let's pop back to the slides. Let's do a bit more theory. So let's have a look at some meanings and some definitions of the terms global variable, local variable, and scope. So a global variable is the type of variable that we have been using up until now, right the way through your course and in previous videos as well, because a global variable is one that's available throughout the whole of your program, and that includes within subprograms as well. Now, in contrast, a local variable is a variable that is only available within the subprogram where it's defined and used. So the term scope relates directly to the concept of the global and local variable. We say that a local variable has local scope. In other words, a scope that is restricted to a subprogram. A global variable has global scope, meaning that it's available throughout the entire program. So what you can see on the screen is an extract, a screenshot of an extract of the code and solution that we've been working on. I've put some pink boxes around our subprograms so that you can see them more easily. So let's start off by identifying our global variables. And by the way, guys, when we talk about scope, global and local variables, that also applies to constants as well. So let's look and see if we can identify any constants and variables that are global. So of course we have one here, which is MSG. All right, we defined that as being a constant and we gave it a value, all right, of a string data type. We also have another two here. Well, in fact, these are variables. All right, so message will say is a global, MSG is a global constant, number and type are global variables. So let's follow the process of what happens when global variables are used to feed the parameters of subprograms within the main code. So let's take our constant first of all, MSG. Our constant is passed initially, or it's set as one of the parameters, or the only parameter in this case, of our subprogram print intro. So what then happens is that the value of MSG, which is a global variable, is copied to, let me just get my arrow there. Okay, so the value of the global variable MSG is copied as part of the input parameter of the print intro subprogram. Now, I've been a little bit naughty, guys, actually, because it's a constant, so I should have defined my output message variable name as a constant, but I didn't do that. But I think you'll get the message here, I hope, is that what we've got is a global variable initially as the parameter of the subprogram when we called it, and then that value is copied across to a local variable called output message. So what that means is that once that's been copied across and associated with the variable, which should be of constant, called output message, and hence its value is only available, okay, it's only available within that particular subprogram. So the scope of the subprogram essentially is the pink box on the screen. That's the scope, and the scope is local to the subprogram called print intro. That means if we try to access the value of output message outside of the pink box, then Python would give us an error. It wouldn't recognize the variable. Likewise, guys, let's do something similar with our function called calc_trig. So we have two global variables which are used as the parameters when we call calc_trig. So we have number and type. So when number is passed across to calc_trig, the value of number is copied across to the local variable called num, and likewise the value that's been assigned to the global variable type is copied across to the local variable trig type. Okay, now once that copying has taken place, it means that num and trig type, and hence the values that have been assigned to them, are only available within this program. Okay, so there are examples of num, and in every case the value and those variables are not accessible anywhere outside that pink box. So the scope of the variables num and trig type are limited to that pink box. Okay, so they are local to the pink box, and that pink box represents the subprogram called calc_trig. So it's that little block of code, and that is why down here when we tried to access and print the value of num, can you see that at the bottom of the screen there, guys? When we tried to access and print the value of num, Python would not let us do that. It came up with an unresolved error message, and that's because it couldn't find the variable num. Num has a scope which is restricted to the pink box, so everything outside that pink box, or in other words the structure of the calc_trig block of code, cannot be accessed. It's a local variable. So hopefully, guys, that helps to explain the difference between a local variable, global variable, and scope, and hopefully explaining it in terms of the process of how values are passed between the main program and your sub programs is quite useful as well. Now, of course, the same thing works in reverse in a way, because num is not accessible outside the scope of calc_trig. When we return num, okay, so here's num being returned as an example. All right, that basically means that that value has to be assigned to another variable for it to be utilized. Okay, so that gets passed back to the main program. It can't be accessed until it's returned back to the main program. It's normally assigned to a variable. We can actually evaluate it within the context of, say, a print statement, but nevertheless it cannot be evaluated until it's passed back to the main program. So is result a global or local variable, guys? Well, result must be a global variable because it has been first defined and used outside a subprogram. So that means that result is in fact a global variable as well. Okay, guys, that brings me to the end of this video. I hope it's been useful for you. In the next video, we're going to look at ways in which we can use Python collections, in other words, a list, to work with subroutines as well. And that enables us to both pass and return back multiple values contained within a single collection. Okay, I will see you in the next video.